Hello student, some of the students have requested me to solve the numericals of the January exam so that they want to check their answers. So I am just solving the numericals which I given in the January exam. So the first numerical was on the chapter electricity. Calculate the total resistance, total current and current through 3 ohm resistors. In this we have to find the total resistance of this circuit, total current and current through 3 ohm resistor. So first let us find the total resistance. Now these two R2 and R3 they are connected in parallel and the combination of this and R1 they are connected in series. So first we'll find these two that they are connected in parallel. The formula as we know is 1 upon R dash is equals to 1 upon R2 plus 1 upon R3. So 1 upon R dash is equals to 1 upon 3 plus 1 upon 6. Let us solve this. This will become 6. 2 plus 1, that is 3 upon 6. We'll cancel it. This will come 1 upon 2. So R dash is equals to 2 ohm. Now the combination of this and R1 they are connected in series. So R is equals to, that is the total resistance is equals to R1 plus R dash. So R is equals to 4 plus 2 and that is equals to 6 ohm. So the total resistance is 6 ohm. Now we have to find the total current of the circuit. So V is equals to IR and total potential difference is 12 is equals to I into R is 6. So I is equals to 12 upon 6 and when we will solve this, so I is equals to 2 ampere. So the total current of the circuit is 2 ampere. Now we have to find the current passing through 3 ohm resistor. This is, I have seen when I am doing the correction, most of the students have done this part correctly, but the third part, that is the current through 3 ohm resistors, they have done it wrong. So let me do the correction. Now for finding the current passing through 3 ohm resistance, we have to find what is the potential difference between BC. This 12 volt is the potential difference of the total circuit. Now what we have to find the potential difference between BC. So first we will find that. So that is noted by VBC. That means the potential difference across BC. That is equals to I, that is the current, and this R dash. That means the resistance of this, the equivalent resistance between B and C. So the potential difference across BC is equals to total current that we have calculated, that is 2 ampere. So 2 into and the resistance of equivalent resistance of BC that we have calculated earlier is 2. So we'll put here 2. So potential difference across BC is equals to 4 volt. So between BC it is 4 volt. The total resistance is 12 volt, but between BC the potential difference is 4 volt. Now we have to find the current through this R2, that is 3 ohm resistor. So again we will write BC is equals to I2 R2. Now I have taken the current passing through R2 as I2. So let us, this is 4 and this is I2 we have to calculate, and R2 is 3 ohm. So I2 is equals to 4 upon 3 and when we will solve it, it will be 1.33 ampere. So the total resistance is 6 ohm, the total current is 2 ampere and the current passing through R2 is 1.33 ampere. Now the second numerical which was there in the paper was a convex mirror used on an automobile has 3 meter radius of curvature. If a bus is located 5 meter from the mirror, find the position of the image. Now here it is given the radius of curvature is 3 meter and we know that the focal length of the mirror is half of the radius of curvature. That means F is equals to R upon 2. And here it is, since it is on the right hand side, according to the sign convention, so it will be 3 upon 2. That means it will be positive if it is on the right hand side. So 3 upon 2, that is 1.5 meter. So the focal length of the convex mirror is 1.5 meter, and the object is placed on the left hand side, so it will be negative, so it is minus 5 meter. It is written that a bus is located at 5 meter from this mirror. And now we have to find the position of the image. So we know the lens formula, so mirror formula, 1 upon f is equals to 1 upon v plus 1 upon u. 1 upon f is 1.5 is equals to 1 upon v plus 1 upon u. U is minus 5. So we'll solve it. It becomes 10 upon 15. That is equals to 2 upon 3. 1 upon v, and this will become minus 1 upon 5. Now this minus 5 I will shift this side, so it will become 2 upon 3 plus 1 upon 5 is equals to 1 upon v. So we'll take the LCM. 15 and 5 to the 10 plus 3 is equals to 1 upon v. So I will solve it here. So 13 upon 15 is equals to 1 upon v, and when we'll solve it, it will be v is equals to 15 upon 13. So v is equals to 1.15 meter. So the position of image will be 1.15 meter behind the convex mirror. Now let us solve one more numerical which was given in the paper. A 2 cm long pin is placed perpendicular to the principal axis of a convex lens of focal length 15 cm at a distance of 25 cm from the lens. Find the position of the image. This is the rough ray diagram I have drawn here to make the question easier. Now in the question it is given that the focal length is 15 cm. So in the convex lens, the principal focus is on the right hand side. So the focal length will be positive, and that will be plus 25 centimeter, plus 15 centimeter, sorry, plus 15 centimeter. And the object is placed since on the left hand side, so it is minus 25 centimeter. And now we have to find the position of the image by using the lens formula, which is 1 upon f equals to 1 upon v minus 1 upon u. 1 upon f is 15 is equals to 1 upon v minus of minus 25. So let us solve this. 1 upon 15 is equals to 1 upon v plus 1 upon 25. We will shift this side. 1 upon 15 minus 1 upon 25 is equals to 1 upon v. Take the LCM. 75. That will be 5 minus 3. That is equals to 1 upon v. So we'll solve it here. 1 upon v is equals to 5 minus 3 is 2 upon 75. Then v is equals to 75 upon 2, and that is equals to 37.5 centimeter. So the position of image is 37.5 centimeter on the other side of the lens. Now let us solve another question from the paper which was based on resistance and resistivity. In this question, the figure below shows 3 cylindrical copper conductors along with their face areas and length. Compare resistance and resistivity of 3 conductors. Justify your answer. Here there are 3 conductors whose surface areas and the length is given. Now as we know that the resistance depends on the area of cross section and the length of the conductor. So let us see how it will affect. Now we know that R is equals to rho L upon A. So the resistance of this we have taken as R. Now let us take the resistance of this conductor here, that is denoted by R dash is equals to, and that is given by rho L dash upon A dash. So R dash is equals to length, it is 2 times, so it is rho into 2L upon area of cross section is A upon 2. Now let us solve this. R dash is equals to rho into 2L into it becomes 2 upon A. So R dash is equals to 2 2s are 4 rho L upon A. So R dash, that is equals to 4 times the resistance. So if it is R, then the resistance of it will be 4 times. Now let us calculate the resistance here. Here R dash will be equals to R double dash, I am denoting is rho L double dash upon A double dash. Now let us see what is the length here. Length is L upon 2. Rho L upon 2 upon, and what is the area here? 2A. So let us calculate the new resistance. So rho L upon 2 into, this will become 1 upon 2A. So 2 2s are 4, so it will become 1 upon 4 rho L upon A. So it will be 1 upon 4 R. So the resistance of the first conductor is R, and the resistance of the second conductor is 4 times, that is 4R, and the resistance of third conductor is 1 upon 4R, that means 1/4 of the original resistance. Now regarding the resistivity, as we know that the resistivity does not depend on the area of cross section of the conductor and the length of the conductor. So the resistivity of all the 3 conductors will be same. Resistivity of all 3 conductors, copper conductors, will be same. There will not be any change in the resistivity.